In this video, I want to go over what will be the last step before you apply any finish to your footstool parts, and that's easing the edges or chamfering the edges. That would be another way of describing it. So we've got the top, and the edges are, this is really nice looking wood. This is going to finish nicely, but all the corners are very sharp. And by corners, I mean everything. I mean this one, this one, this one, the point of the corners, the underside. They're just way too sharp. They're pointy, they're kind of uncomfortable, and they're also prone to breaking, and they won't hang on to the finish very well either. So what we need to do is to stop them from being perfectly 90 degrees. We need to make them a little bit round, or actually, ideally what we want is a 45-degree facet on these corners, but very narrow. You know, a 1/16 of an inch wide would be plenty wide for this. There's two ways to ease the edges on woodworking parts, and one is by hand, and it's what I recommend you do. You don't want to do this without some sort of a block to support your sandpaper, and you want to use some fine sandpaper too. So this is a piece of 220, and I'm just going to go over this. I've got my block at 45 degrees, which is what I want, and I'm just going to push it all the way. And that's about it. See how nice that looks? And it's even too. That's another factor. So there's not much to it. I'll do a long edge now. There. It feels a lot nicer. It looks nicer, and it's going to last better too. This is eased. This is eased, and I'll do all the other edges and ease them too. But you don't want to forget this. This is also very important to do that. Now in practice, when I get all of the pieces chamfered, I'm going to examine each piece with a piece of 220 grit sandpaper in hand, and I'm just going to examine it, just maybe kind of go over the edges a little bit, just a stroke or two, to make sure everything's absolutely perfectly ready to go. So that's the hand method for making chamfers. There is another method too, and it's actually one that I prefer because the width of the chamfer is always perfectly consistent, which is a nice thing. And to make that happen, I like to use a router. Now, you don't need to buy this right away, but as usual with the course, I'm pointing ahead to things that you might want to get in the future. A router is nothing more than an electric motor with a shaft that can spin a bit. That's basically it. This is about as small as they get. You can get small ones in a cordless form. They also get much larger. Two-handed tools. My biggest one has the same horsepower rating as a push lawnmower. So a lot of variation there. All routers spin their bits very quickly, anywhere from 20 to 25,000 RPM. And RPM, those letters stand for revolutions per minute. So that's how many times in a minute it spins around. 20 to 25,000. Very fast, and it has to go that fast in order to cut the wood. You can see this router here. When I use it, and I will use it in a minute, spins like this, and those are the cutting edges. They need to move very, very quickly to cut the wood cleanly, but it will, as you'll see. Now when it comes to routers, the depth of cut, so how deep the bit goes, determines how wide of a profile it cuts. So I can loosen this, and now I can rotate this wheel, and I can make it, the base, go further out, or, well, that's too much, but, or further in, to make, in this case, a very wide chamfer. All of this is why I would never put a router like this directly on a workpiece that I cared about without first testing it. I want to test it. I want to see what kind of chamfer width it creates before I commit to my actual parts. So I'm thinking that something like that will probably be the right amount. But as I said, we don't want to guess. We want to know for sure. So I'm going to grab a piece of scrap wood and we're going to try this out, see what kind of a chamfer we get. I've just grabbed a piece of scrap wood from my wood rack and it's here. It's not sanded. It's not the same thickness as our work pieces, but that doesn't really matter. All I want to do is see what width of chamfer the setting on this router is going to create. With any kind of power tool, beyond maybe a cordless drill, you should protect your ears and your eyes. That's another part of the teaching tangent things that I'm handing you your way. You don't need that sort of stuff with hand tools, but it's loud enough that it's going to harm your hearing in time. And even though the chances of something flying up and hitting you in the eye are very slim, because this tool is used this way, so the cut is kind of contained, it's still a great idea to put on safety glasses when you're doing this. I personally just really prefer especially to be wearing hearing protection, even when I don't necessarily need it. I just find the peace and quiet to be a little bit nicer that way. Before I put my goggles and earmuffs on and fire this up, I just want to show you how this works. This is what's called an edge forming bit. And the reason it's called that is because this thing here, this is a bearing. I'm spinning it. It spins nicely. The bearing is designed to guide the tool as it travels along the edge of the workpiece. So without this bearing, there would be nothing to prevent the tool from going right in and just making this massively big chamfer. There'd be nothing to guide the tool. But if you look here, can you see that? Can you see how the bearing is riding against the edge? That's key. All edge forming bits have a bearing like that. And by edge forming, I mean any bit that is meant to change the look of a square edge of a piece of wood. That's a very common thing. Not all bits have that because there's different bits for entirely different purposes than this. But I expect that when you do get a router, if you do, the first sorts of bits you're going to use are edge forming bits because they're the easiest to use. They provide the most dramatic effect too. So time to safety up and switch on now. One other thing before I get going. It's essential that the direction of travel of your router is always against the rotation of the bit. So come and take another close look again here. This bit is going to spin like this. So that's the cutter there, and the cutter is encountering the wood in this direction. I want to move the router against that movement. So if it's spinning this way, and all routers do spin this way, by the way, then I'm going to be moving the router from left to right. So that's something to remember. Don't worry about it. You don't need to memorize it just yet, but you have to understand that all routers spin in the same direction, and when you're using the router in your hand, like I'm going to do, you want to move it from left to right. If you moved it the other way, there's a chance that the bit would catch the wood and start to propel the router, which is not what you want. It wouldn't really be a big deal with a small thing like this, but it can be a big deal with a larger router. So handheld routing, left to right. Routers are also mounted sometimes upside down in tables, so they become a stationary tool. And in that case, in order to preserve the correct movement of the workpiece against the bit, you then need to move the workpiece from right to left, not left to right as you do with a handheld router. So don't stress out about that. I'm just mentioning as a teaching tangent. I'll be talking more later in the course about routers and things. But for now, let's just test this setting, see what it looks like. I think that's just about perfect. That's a little bit of a bigger chamfer than I put on the pieces with the sandpaper, but it looks nice. Still looks like a square edge, but it's just nicely eased and refined. And as you'll notice, as I mentioned before, because it was cut with a router, that chamfer is absolutely perfectly consistent across its width and along the whole length. I'm going to do all of the footstool pieces now with that router, and then we should be getting pretty close to starting the finishing process. And here you can see a close-up of those routed chamfers. Notice how they come together so nicely with a kind of a facet right in the point of the outside corner. There's something I forgot to mention. Do you remember I told you about the bearing and I showed you how it rides along the edge of the wood to regulate the cut of the bit? Well, that bearing, when it's touching the wood, it's not spinning. I mean, it's a bearing, so there's a central portion of the bearing, and that's spinning with the router bit. But the outer face is not spinning. It's just rolling along the edge of the wood. And even though I was very gentle with that, I wasn't pushing the bearing hard into the wood, it has left a line here, a little bit of a indentation in the wood. It's not unusual. Much more common with softwood than hardwood, of course, as you'd imagine. So you don't want to leave that line there because that's going to come out when things are finished. The solution to the line problem is just a little bit of hand sanding. It doesn't take much because that depression is not very deep. There. It's pretty well gone here. Just a little thing to remember. Won't take you long, but it will make a big difference in the quality of your finished project.